Good morning, good afternoon, and thanks for attending this conversation with Caroline Chine at Intel. She is the Vice President in the Data Center Group and the General Manager of 5G Infrastructure Division at Intel. And today, this conversation is part of a report on analytics and more generally, how we optimize the data in a network where of increasing complexity, where we know a lot about what's going on in the network, and we need to optimize it for different services, for different applications, different network technologies. So we're talking with Caroline to see what's the perspective from Intel. And Caroline, thanks for being with us today.
Oh, thank you for having me.
It's always a pleasure talking to you. So to get started, can you tell us a bit about in all this these efforts to optimize and making sure that the network perform at their best? What is Intel's perspective on this?
Well, so first of all, every time we talk about the network, we always think of the network as an extension of the cloud. So it needs to be soft and needs to be flexible. So it's here at Intel, we've been working on different prototypes and reference architecture to extend that. So the perspective related to the discussion we have today around how does the 5G infrastructure really aid in all this big data analytics and all this coming data tsunami, we really think about the network as an integral part of it, and having to make that more cloud-like, because we know that a lot of the data today is being stored, analyzed in the cloud. We wanted to make that being aided the audits analytics that were coming from the edge, coming from all the devices that's going to be out there collecting all the information. And later on, I think we'll touch upon that not all data is equal and how do we pick the right data. So you don't get overwhelmed, but you pick the useful ones to really help the enterprise make the right decision. So the network needs to be not too hot, not too cold. It's our way of saying that the network needs to be flexible, sliceable, and in order to manage all of these expected amount of data that's going to hit us all.
Right, and you know, I think it's really crucial. You know, flexibility. It's really crucial in a network where all sorts of things happen at the same time, and you cannot be too strict. You need to be able to react to everything. But at the same time, what you're seeing, and when operators talk to you, they feel overwhelmed because there is so much data, and the data doesn't sit in a neat box. And there is the cloud. You need to pay attention to what the users see. So it's very easy to get overwhelmed by the sheer amount of data, and you need to find what's relevant in there. How do you go about it?
So I go back to quite a few years ago, we worked on a world fair in Shanghai with the local provider. And one of the issues that we're facing was that they have security cameras all around. Obviously, this is a big event, and security is always top of the mind. They were just taking every single frame and going to the cloud. That's just overwhelming. It was a very large site, a lot of people. So we worked on with our customers and partners locally to take the data, and they have a certain criteria where they select. It was like in July, so looking for people wearing unseasonably warm clothing, big backpacks, other movement, and so sometimes local public safety folks will tell you look for certain models of car. Maybe they have some a target in mind. You really don't need to bring everything back. The idea is at the network's edge. That was the early version of MEC. If you remember, Monica, we've been talking about that for a while. Really just do some analytics and then take the right frame of data that's back to the local authorities. So we started that, and now it's really down to if you look at some of the connected car, autonomous driving, there are road hazards around the corner where out of line of sight that you need to capture. So we really come a long way from this is back in 4 or 5 years ago, and down to now, we were able to do a lot more analytics and based on more advanced Mac technology and compute technology to take the frame by frame camera frames and compose the video showing the passengers in the car what kind of a police action, public safety actions happening 2 miles down the road, in a way to explain to them why they're taking a different route than what they normally take to work. So things like that becomes a very integral part if we want to make something like autonomous driving successful. So this is something that we're actually showcasing in our autonomous driving garage in Intel campus in San Jose. So that was just one example, but if you extended that to many scenarios, even if you look at network management in our wireless network, that has a useful applications as well. So really, the funny thing is, if you provide the right API, if you provide the platform and the API that exposed to developers, people do come with applications that's meaningful and useful to manage the data. And it's not just like data for a horizontal. So a lot of times it's a very vertical focusing data for the specific targeted enterprise.
Yeah, absolutely. Now let's get to the vertical distinction layer, because that's really a huge part of analytics. A huge opportunity for optimizing the networks. But let's look at the sort of horizontal level, so the centralized versus distributed. Now, the obvious goal is to optimize end-to-end, provide the best quality of experience to the end user. The question is that where is the best place to act within the network, within the end-to-end network, to ensure that? Where do we collect the data? Where do we act in terms of from an analytics point of view?
We see this as a hybrid model. So there are reasons to do centralized analytics, because at the end of the day, we know that cloud tend to have a large amount of computer storage, and when it's centralized, the cost does go down. And the distributed analytics architecture, like fog, like mobile edge compute, it has its place as well, because it helps extract all the value from the IoT endpoint device data. And also as a way of taking the cloud-based learnings, distributed that back. So it allows to spread the data and analytics workload over multiple nodes in all a cluster of servers, and instead of asking one single node to tackle a very big problem. So remember, if this algorithm runs across many of the nodes, it forms a cluster of the data. Many times the data is very meaningful locally. Locally in one node, and also locally in several adjacent nodes. We actually been talking with some of the machine learning innovators out there that they are actually experimenting with that. So to summarize, some of the data when it should go to the cloud, to centralized learning that belongs to the cloud. But there's a rightful place for distributed analytics as well to get a faster response, faster insights. Think like autonomous driving car, road hazard situation. You need to get a very, very low latency and instantaneous localized response. That can be done locally, but the big learnings and so on should be done in the cloud. So we see this as a hybrid. That's what the path we are pursuing.
Yeah, and I think that's interesting, because it's not analytics like pretty much anything in the network. You had this huge centralized one location from where you act. It's so some is distributed, some is not. So it's not even a fixed structure. It really depends on at the application level. What is it you're trying to achieve? What network you have? So it's not deterministic. It really and then again, it goes back to the fact that you mentioned the need for flexibility.
Yeah, exactly. I mean, way back when we were doing the SON, everything was going back to the NOC, and NOC makes a decision. There's some latency involved, and so on. But now, with all these, it was okay because a bunch of macro base stations. Now you have macro base stations, and you have all of this small cells out there, Wi-Fi APs. the problem, the interference issues are a lot more distributed. So if getting everything back to the cloud to make a sound decision, it may not be as efficient as if you do both of a distributed SON and a centralized SON. So the trend, based on what I'm reading, is really going both ways. I think that's another good example of the hybrid architecture on this. And then you're taking the different verticals, factories and robotics and driving and so on. I think the example just goes on and on.
Mm-hmm. Right. And you mentioned latency and timing, and that sort of brings up another crucial issue, which is real time.
Mm-hmm.
We need to optimize networks based on historical data, periods of weeks, months, and whatever. And that's still good, but not even close to be enough. So we need to move to real time. How do we do that? What are the enablers here? How do we go about it?
So we have a couple of tools and fog and mobile edge compute. So by moving the intelligence closer to the edge, it helps reduce the latency significantly. If like was last year, there was the trial that Nokia and Deutsche Telekom and did in A9. That was one example showing that in LTE, a road hazard situation through MAC along the A9 was able to get all the information, necessary information. There was a car breakdown, even out of sight to all the cars around it. So that's one example. Of course, 5G, it's the fact that the standard is going to be structured that you will have tackle the latency issue. That also helps. So there are multiple ways to tackle skin this cat, but MAC starting today, we see that as very critical to solve the issue. In fact, we've been now calling the network is a distributed data center. Distributed centers across the network, so you don't make every decision until you get to the core. You start pushing some of the intelligence out to the edge. The minute the RF becomes IP, you start making the right decision at the right place. That's one way to reduce it.
Yeah, absolutely. And then if we can go a step further, we need to not only act in real time, we need to act before real time hits, because you want to, whenever there is an issue in the network, whenever you need to change something in the network, it doesn't necessarily mean there is something going wrong. Mm-hmm. But in order to optimize, you need to do it ahead of time before you get to the situation where you hit the problem. So you need to be able to predict.
Yeah.
How do we do that?
Yeah.
Or can we do that?
Well, actually, preventive and predict. So it goes in some of the discussion we've had with the verticals, right? And like car manufacturers or airplane, and a lot of the things about they have all the information, engine data. Today is collected. They don't necessarily be able to offload all these efficiently, effectively. There's always a cost involved when you start bringing all these data towards the cloud. So backhaul and so on. So we start tackling this at multiple ways. Number one is put in the MEC, so you run some local, and first of all, get them off the engine before the engine gets rewritten again, and run some local analytics, having a effective and consistent connectivity at the edge, so you get the information. And many times we learned from these enterprises that by having enough data, they actually can get some preventive, or you call it prediction. There's a trend that they know that how many times you send on a plane and they only have the pilot announce that there's a light that they won't turn off. I'm gonna call the maintenance, then call the mechanics to come on, and that's easily an hour later and before anything happens. So typically, if you can get the data, even to predict 15-20% of the engine failure that to come, that's a huge savings. Again, the data is there. Many times the data is there. The question is, get the right data. Not all data are equal. Get the right data, do the analysis, so it allows the enterprise, the smart people to predict.
Yeah, absolutely. So We talked about timing, distributed, but now let's look at the vertical part. So the sort of orthogonal direction to this, which is the different vertical markets that are opening up with the IoT and IIoT. So it used to be that it was just a bunch of us with a phone, and that was easy. Now you have many different devices, different requirements out there. So there is more of a scope for optimization, but it's also more complex. How can we survive this complexity?
So network slicing, I just came back from the 5G Americas and the BCE conference. I was participating in 3 different panels: 5G economics, 5G use cases, and all of it really comes down to the need for operators to utilize the network more efficiently, because they are, like you said, facing a myriad of verticals and enterprise they do serve. The reason is to serve the enterprise, they will be able to monetize their network investment much better. But every verticals have their specific needs. You can't really build, well, I guess you could build a network fit for all. That just means that you tend to over provision. That was in the past. When I used to work in this industry, we were used to do this thing called tornado effect. Whatever algorithm we write or resources we block, we always had to making sure that there will be that one day in a season, a quarter, that the traffic just goes through the roof, and you need to make sure you account for that. But that means 99% of the time you underutilize your resources. So it goes back to having a soft network, a virtualized network, so you can move the resources to where you need to. And the other important thing is network slicing, so that you can give the right amount of resources, or the right type of resources for the type of application that you'll be running. And you can switch it around when the application moves away. So network slicing, SDN, NFV, that's a theme that we repeat in all those panels, and everybody tend to agree. You got to move away from the fixed function network into a more soft and flexible network.
Yeah, absolutely. And you mentioned network slicing and MEC. Can you tell us a bit about how do you see network slicing and MEC working together within the analytics framework?
So when we look at network slicing as the enabler, MEC is a principle that we saying that the network's edge for either eNodeB or right next to eNodeB needs to do more than just processing the call according to switching PP. You need to do that and more. You need to have the intelligence of the analytics analysis. So that is a tool, a philosophy that we're putting into our reference design, into our silicon roadmap. In addition to that, network slicing really becomes enabler. Without network slicing, can you do analytics? Yes, you can, but you will do it at a much higher cost and not as efficient. At the end of the day, there's only a certain amount of money that gets flowed through. You need to control your costs and how to serve that. Actually, when I'm listening to the keynotes after keynote from AT&T, Verizon, T-Mobile, in Austin, everybody's go back to the same principle: is that the network must be flexible, the network must be sliceable to use the right resources to enter in some perspective as the right spectrum for the right application. So we think it's very, very tight together, enablers and the design principle.
Absolutely. Now, let's look at it from the enterprise point of view, because a lot of the IoT is going to be driven by the enterprise. Yeah. How is that benefiting them? What type of applications? What are they doing in this space? Because once they deploy IoT, they're going to become much more involved in a more active way than they have been in the past.
Yeah, it's so funny. When we started thinking this, we thought that we had to sell this to the operator and to the enterprise. What it turns out is that when you go to the enterprise side, you really sit down and understanding their problems they want to solve. Most of them wanted to do what they call digital transformation. They know that the business model and the business practice has to be more automated and consolidated. And if we gave them, at the end of the day, you want to give them a flexible platform with the API that allows them to run their current applications that are already running in different parts of the network. Many times it's in their enterprise cloud or in the public cloud. And you allow them to tie it into the connectivity, because many of these applications either running on a Wi-Fi or not at all connected. You show them a way to say, well, here's a platform. It's very CIO approved. It's IT friendly. It runs on a x86 architecture, means that your existing application do not have to be rewritten. It just runs on this platform. And we found them start changing the conversation from why doing this to how do I do this cost effectively, and what what problem can I solve in addition. So the conversation really changes. We found the enterprise starts driving the conversation, driving the proof of concept and the timeline. And then the operator comes in and say, well, here's your LTE now. And then sometimes, upgradable to the 5G in 2018-19 timeframe. Most of the conversation, we don't even wait till 5G is available. We're actually doing that right now. There's some rollout, there's some early trials happening, proof of concept in the lab. We found the enterprise very much buying to this. But first of all, you need to remove that, oh, this is a LTE or this is 5G, but show them this is your enterprise application runs on this server platform with a connectivity. Once you change the dialogue, it's the CIO much more willing and able to discuss this with you.
Yeah, absolutely, absolutely. And we're going to see more and more of the enterprise taking, bigger role in this.
Yeah. Yes.
Now, analytics sort of, not all of a sudden, but recently has become a really hot topic. Everybody talks about analytics, big data, and AI, machine learning, and all that. Why is it happening now, you think? Why not 3 years ago?
Well, I actually, big data analytics been around. AI has been around. I was listening to
been around for 20 years, but the hype. Okay, let's put it this way: the hype on it. Mobile World Congress was much bigger topic this year than it was the previous years. Let's put it that way.
I personally think that the fact that multiple fact, obviously going to have the ability to do a much faster speed and connectivity helps. The spectrum is availability now extends beyond the typical 20 megahertz, which, well, is good for browsing network, browsing download. But now with a wide variety of spectrum, it enables one huge factor. It really is SDN and NFV. Before then, it's such a fixed function network designed for voice. We have voice over LTE, but it really doesn't. It's very much tied to a human. And now you have this concept, and also this whole push to say the network need to also handle wide varieties of machine types out there. And you have a network, at least in the design principle, is so friendlier to IT because SDN, it's, the biggest issue is that it looks like a server, it talks like a server, runs like a server. When you have that, the AI who used to run control in the cloud says, well, now I can probably get that closer to in the factory floors, in a publishing house, in a stock market, a broker's office. So it becomes much more industrial friendly and healthcare friendly if it runs in the hospital. So it becomes, I think the conversation starts shifting away from an elite group of people runs AI to AI can be delivered to ordinary Fortune 500, Fortune 5,000 enterprises. I was just in Rio, Brazil, attending the 5G Latin America, and we're talking with all different enterprises. Their government officials are very interested to say, oh, well, now that we have this potential, having this very flexible network connectivity, we're showcasing some AR, VR. How does that transform my economic? And by the way, they're not talking about like flying drones per se, or autonomous driving car. They're talking about agriculture. They're talking about ranching. They're talking about, can I get 5G to the cows, helping with milk production and meat delivery production. So you see, once you give people the tool, the conversation changes from elite groups of intellectuals and the top tier echelon of enterprises to everybody, to the ranchers and farmers, right? And what does the government want? Government wants to uplift the economy. Look at what's going on with China. They just announced One Belt, One Road. What does that mean? It's recreating the Silk Road through IoT and through connectivity. All the way from China to Europe. Used to be done through the camel, now it's done through IoT connectivity. It goes without saying is that if that network is not flexible enough and reasonably cost enough, that will never happen. Then we go back to the camel days.
So moving forward, final question for you. Where is analytics headed to?
I think the analytics is going to head to a much more widespread distributed. Analytics will happen in the cloud, will happen at the edge of the cloud, or happen in the network, and it will permeate through many different verticals. We're just starting right now. We're still very much stuck at some of the fundamentals like healthcare that makes total sense, hospitals, but we should see that going more and more towards into retail. That sounds kind of scary right now. Everybody knows your buying habit. Going into even farms and ranchers. Before I went to Rio, I have no idea that Brazil is such a beef production country. A lot of the GDP is tied up in that. So the conversations around, well, can you run analytics of the cow, of the production, the milk production? A lot of this stuff really impacts people's income. And GDP. So I think analytics will definitely help drive the economy forward, a much more efficient economic model.
Yes, thanks. I like the 5G to the cows.
5G to the cow. How about that? That's a new logo. And 2018, 5G to the cow.
Caroline, thank you so much for being with us today.
It's always fun talking with you, Monica.
Thank you. And this conversation was part of a report on analytics from Sense of Healy, done in collaboration with RCA Wireless. And thank you all for listening in.